So on the next problem based on CDF, that is cumulative distribution function. So first problem based on CDF. That is cumulative distribution function. So 3-digit message is transmitted a 3-digit message is transmitted over a noisy channel having a probability of error P of E is 2/5 per digit. Find the corresponding CDF. Find corresponding CDF. So this problem was asked in exam. So P of E is given. It is 2/5. Next, now consider P of R. It is probability of receiving a right digit. Probability of receiving right digit. So it is P of R is 1 minus P of E. It is 3/5. So for 3-digit pattern, we write here for 3-digit pattern, the error can occur in the following ways. The error can occur in the following ways. So sample space S is Now depending on the number of error, we write here depending on the number of errors in the bit we can define random variables which can be represented as it is RRR so this point is x0, this point is x1, it is x2 and it is x3. So this point is no error. Here it is one error. Next here is two errors and here three errors. So here points are for no error, for one error, for one error, also this one for one error, also this one for one error. Next for two errors here. So it is two error, this one is for the two errors, this one is for the two errors, and for three error this single one only. Now our random variable will be defined as, we write here, therefore random variable will be defined as x of no errors, one error, two errors and three errors. To find the CDF, we write here, to find the CDF for discrete random variable, for discrete random variable f(x) of x is 0. This is for x is then 0, and we write here summation for this, I from 1 to 3 p of so this value is 1 for third condition greater than x3. Now p of x is equal to x0. So probability of it is, so this value is 27 by 125. So it is therefore for, or we can say therefore fx of x0 so this value is 27 by 125 plus 0. Therefore x1 is that is with single error, or we can say one error. The next one, therefore p of x is equal to x1 is p of r, p of r, p of e plus plus so we have to make the addition of all these three. So it is 3 by 5 into 3 by 5 into 2 by 5 plus plus so it is 3 times 3 by 5 into 3 by 5 into 2 by 5. So this answer is 54 by 125. Next is f of all three conditions addition (81 by 125). So similarly p of x equal to x2, it is 3 into 3 by 5 into 2 by 5 into 2 by 5. So it is 36 by 125. Therefore fx of x equal to x2, it is p of plus p of x1 plus p of, so we have to make the addition of 3. So it is 0 plus 27 by 125 plus 54 by 125 plus 36 by 25, and its answer is 117 divided by 125. Also p of x is equal to x3, so it is 1 into 2 by 5 into 2 by 5 into 2 by 5. So it is 8 by 125. Therefore fx of x equal to x3 is p of x x0 plus p of x equal to x0 plus p of equal to x1. So here addition is 0 plus 27 by 125 plus 36 by 125 plus 8 by 125. So its answer is 125 by 125, which is equal to 1. Now the probabilities of the random variable x can be plotted here. So we write here the probabilities of random variable x can be plotted as, so this is x, this is p of x equal to x1, this is 0, 1, 2, 3. Here this value is, for 0 it is 27 by 125. Next value is 54 by 125. Next is 36 by 125, nearly equal to this, 36 by 125. And next is 8 by 125. So it is 8 divided by 125. So this diagram shows the probabilities of random variable x. Next is the cumulative distributive function. So we draw here cumulative distribution function can be plotted as, that is CFD can be plotted as, so this is x, it is fx of x, this is 0, 1, 2 and 3. Now for 0 the value is 27 by 125. Okay, for 1 the value is 81 by 125. Here it is. For 2 the value is 117. It is 117 by 125. Okay, and for 3 the value is 1. So we can draw so this graph shows CFD, that is cumulative distribution function. Now next problem was also asked in exam. A coin is tossed 3 times. Coin is tossed 3 times. Write the sample space. Write the sample space which gives all possible outcomes or possible outcomes. A random variable x which represents the number of heads obtained any double toss draw the mapping S on to the real line. Also find probabilities of X and plot the CDA. The problem was asked in exam for 6 marks. So here let 0 represent head and 1 represent tail and 1 represent tail. Therefore sample space S is 0 0 0 0 0 1. Now let x0 is 0 heads, x1 1 head, x2 2 x2 2 heads and x3 3 heads. So this is 0 0 1 sorry 0 0 0 0 0 1 0 1 0 0 1 1. Now this is x, so x0, x1, x2 and x3. 0 head, 1 head, 2 head and 3 head. Now for 0 head, here we have considered 0 for head and 1 represented. So for 0 head, that is this one. Okay. Now for 1 head means 1 0 only. So 1 head, that is 1 0. This is 1 head, that is 1 0. This one is 1 head. Okay. Now next is 2 head. 2 head means 2 0. So this one 2 head, 2 head, 2 head. Next x3 is 3 heads, that is 3 0. So this one is 3 zeros. Okay, so number of heads obtained in any double toss, we write here number of heads obtained in any double toss is x. Therefore, P of x is 7 by 8. Now, P of x0 is 1 by 8. P of x1 is 4 by 8. P of x2 is 2 by 8. And P of x3 is 1 by 8. So, we have to draw the CDF now. Therefore, CDF is drawn here. It is x. This is x, not 0 here, x0, x1, x2, and this is x3. Now first is 1 by 8. For this x1, for this x0. Next for x1 it is 5 by 8. So we give here 5 by 8. Okay. For x2 it is 7 by 8. So this is 7 by 8. And for x3 it is 8 by 8, that is 1. So this is the CFD for given function. So this problem was also asked in exam for 6 marks. In this way we can find the CFD, that is cumulative distribution function. Next is problem based on probability density function, that is PDF. So this problem was also asked in exam, probability density function. So probability density function we write here density function of random variable x is defined as fx of x is kx square, kx and 0 for a different condition. And this condition is for other remaining otherwise. So find first constant k, second p of x greater than 2, p of x, p of 3 by 2. The third one, find CFD and sketch. Find CFD and sketch it, or we can find only CFD. So here we know that area under PDF curve is always unity. We write here, we know that area under PDF curve is always unity. Therefore it is minus infinity to infinity, fx of x is 1. Therefore minus infinity to 1, fx of x dx plus 1 to 2, fx dx plus 2 to 3, xx plus 3 to infinity, fx of x dx equal to 1. So 0 plus 1 to 2 k x square dx. So this is x square dx plus 2 to 3 kx dx plus 3 to infinity 0 dx equal to 1. So we just substitute these values and we get k by 3 2 plus k by 2. So we solve this and we get k is equal to 6 by 29. Now second, in that first one, p of x greater than 2. So p of x greater than 2, 2 to infinity, fx of x dx equal to 2 to 3 fx of x dx plus 3 to infinity fx of x dx. So we just substitute this. It is x square by 2 to 3 k into 9 minus 4 by 2. So it is 15 by 29. Next is p so this value is 14 by 29. And third condition 3 by 2. So it is half to 3 by 2 fx of x dx. So it is half to 1 fx of x dx plus 1 to 3 by 2 fx of x dx. So it is 0 1 to 3 by 2 So the answer is 6 by 29 into 0.245. And the third one, we know that fx of x minus infinity to infinity, fx of x dx. So fx of x for 1 to 2. Therefore, x of x is 1 to x kx square dx. So it is k into x cube by 3, 1 to x. Therefore, fx of x 6 by 29, x cube minus 1 by 3. So we just solve it and we get 6 by 87 into. This is for condition for 2 to 3. Therefore, 2 to x kx dx, it is square by 2, 2 to x. So it is 6 by 29 into 2, x square minus 4. So this value is 6 by 58, x square minus 4. So this is 2, x and 3. Now the last is fx of x greater than 3. So fx of x is minus infinity to x, fxx dx. So this is 6 by 87, x cube minus 1 plus 6 by 58, x square minus 4. This is for x greater than 3. So this problem was asked in exam for 8 marks.